Welcome to all to class number 4. See, last class I uploaded class number 3 around 4 5 days earlier. Some delay. Reasons all I will tell you at the end of the class, not right now. Because not right time for explaining those things now. So I will go for class number 4. See, we are discussing simple stresses and strains main chapter, or what you call unit 1 or module 1 in syllabus. Subpart, new part now, not new chapter. In the same simple stresses and strains, now you are starting compound members. What is compound members? There is one more called member of composite section, which some people call composite members. And one more thing, compound member principle and member of composite section principle, they are completely different. Very easy, I will make it easier. Sometimes what happens is, what I call compound. See, a question you can see here, I will come to the question later. What all they want, I will tell later. This is a compound member. What we call compound, some people call in the question paper composite. Actually wrong. The very word composite has some other meaning. Okay? Or some later we will consider composite, member of composite section. That time some people call it for the given compound member. It is little lack of knowledge. But what you have to do is, you should not solve as per the language used by them. You will be correctly knowing now, as I proceed further here, what is compound and what is composite. So when the question is given, you decide whether it comes under, in my class, it will be always correct. Compound case or composite case, accordingly solve. And note, when you solve, you don't write, I am solving this as a compound member, I am solving this as a composite member. That all you are not writing. You solve. So, what we call compound, if they call composite, usually people call compound. Or what later we call composite, if they call compound, you do not solve by the namesake. How the principle I tell, that way decide. So you decide whether that problem comes under our class principle of compound or composite, accordingly solve. Okay. Now, before I start compound members, this question will come little later. See, first, very important note, not very, I will tell once again, very important note. See, we considered expression delta equal to PL by AE. And also strain energy stored U equal to P square L by, no, this right mark is not power, P square L by 2AE. And remember, the original formula for this is U equal to half P delta. I will tell it later about that one. Okay, now, these two actually both are same. Whatever comes here also. So you stick to one formula. Delta equal to PL by AE means, when you consider U equal to half into P into delta, there if you substitute delta equal to PL by AE, then U becomes P square L by 2AE. Or you can see here, 2 is a constant. So stick to one. If this is applicable, this is also applicable. If this is not applicable, using this only you got, this also not applicable. So are applicable only if axial force P, remember, not direction. See here, axial force P can be compression or tension, comma, cross-sectional area, that is A, and material. Actually, in the formula, there is no material. See, material means, you already know, E, Young's modulus of elasticity of the material. So, E is the property of material. So, in this chapter, if I talk about material property, it is what? Elastic constant. It is Young's modulus now. Later it will become Poisson's ratio. This will become, there are other terms called Poisson's ratio or modulus of rigidity and bulk modulus. One by one will come. They are all material properties. So, this expression can be used only if axial force P, then cross-sectional area. wherever you take cross section, A should be same. And also material means E are all constant for the length considered equal to L. Remember, this which L? L means, you can write here. What is that L? See, the L used here, this one. The L used here. You can make, see, these all you have tried. Remember, in some problem, see, writing problem, I change it. PL by AE. Okay, now okay. This L, this L, this L. Okay. What all I tell principle, remember, you have to correctly make a note and study, not just go through like entertainment video. I told my class will be not an entertainment class, it will be a serious knowledge oriented class. Okay, start now. Now, even if, see, one part is over, you cannot apply this formula if P, A and E and L. Sometimes I have seen people telling P, L and AE are all constant. What L constant? L you can use for any length. Means once you decide for what length L, you apply the formula. For that length L, P, A and E should be constant. Now, one line. Even if any one of the above three, which one? P, A or E. Even if any one of the above three means either axial force or cross-sectional area or modulus of velocity are not constant. Actually, any one means not are, is. Why singular? Is not constant. That is, either P varies, P is not constant, or area is not constant, or material is not constant. See, I told even if any one of the above three, sometimes people are there, they will tell, okay sir, suppose two are not constant. What I can tell for such people? Example I will give you. Examination, they will tell, even if you come by 1 minute late, you will not be allowed for examination. Then you ask them, sir, then if I come 2 minutes late, he will tell, get out from here. He will use a rough language. Even if one of them is not constant means, what? It is not applicable. One of them constant, two are, see, only P may not be constant, or A may not be constant, or E may not be constant. For that matter, see our first question on compound member, which will be called master example or critical example, so that this complete part will be completely clear for you. I taken a question where axial force P changes, area also changes, and material also changes. So here all the three are changing. Instead of coming 1 minute late, you come 3 minutes late. First of all, 1 minute late only they are not allowing. Who will allow you if 2 minutes late or 3 minutes late? So, understood. So, then above expression are not constant, then above expressions cannot be applied for the length considered equal to L. What length you decide, if for that length L, if any one of them, either one or two, all three, they are not constant or there are different values for different cross sections, then formula cannot be applied. Then what to do? It will come. It will come when I start principle for compound members. Okay. Then it will come when I start the principle. Or I will tell you now only, break the entire member into different parts. So that I will write in the board now, for each part the condition is satisfied. See, for whichever part you consider, axial force, cross-sectional area and material are same, then you can apply. That is the principle later. Okay. Therefore, this is a very important note. Go through repeatedly. See, when you study from my class, whatever I tell, you have to follow. I am very strict in that matter. If you have to follow whatever I tell, and you should start from first class, not now. Suppose somebody joins now. No, drop it. Go back from first class. Thoroughly understand. Second class, third class. Each class see 10 times if you want. understand and get complete control, then come here. I told this is not a class where you just come, see and go. That is what so many are doing. I know it. That I will talk in the end of the class, not right now. So, right, see, anything I want to tell outside the subject, I talk separately. In between, sometime I will tell. Because for me, giving knowledge or spreading knowledge is more important, not discussing about other things. So, now this is the very powerful note. Correctly make a note. Now I will explain some more principles for you. That is, I will differentiate what is compound, what is composite. Make a firm note in the examination when you get a question. See, both come in the same unit. They may not tell what we call compound, they can call composite. You can't fight with them. So you decide. Oh, whatever they call, you should decide it comes under whether compound principle or composite. Accordingly solve. Okay, now I will go for some extra, not extra explanation. Now I will differentiate between compound and composite. Later, when I go to composite, I will tell you, go back to class number 4 where I thoroughly told study and once again come back. You should actually tell me at that time, no, we understood, we made a correct note, no need, we know everything. That is the answer you should give. Not tell, okay, let me go and refer there. That means you have not considered earlier. So I will go for second part now. These all I am removing. This will be there because this is a question given. Still I have not given the question. Okay. I will dictate the question little later when I start second round. Okay. I will continue after a while. Now we will continue. See, I am going to give you simple example to differentiate between compound and composite. Remember, later when I go to composite, I will not tell once again. I will tell at that time. Go back to class number, I think 4. I may not remember class number. Earlier class, when I started compound members, I clearly told difference between compound and composite. So, make thorough note. See, compound member, then it is not called composite member. Technically called member of composite section. Of course, you can call composite member, but technically called member of composite section. Okay, start. Just to understand, see, take two materials, two parts, join this way. Okay, now apply a force. See here. Whatever force I apply here will be transferred there. See here. In between force can be there. Simple, Anthony, simple example. Then you can build up the concept. See this way. This is compound. So force from one member, if you apply here, will be transferred to other member. See here, from steel to copper. They may not be same material. They can be of same material. It can be compound because of some other concept. Sometimes that I will use second round now. See, there is no rule that in compound materials are different. It may be different, but in member of composite section, materials should be different. It is need, you cannot tell steel and steel. It is not composite. And see here, see, I told already, compound this way. See, if I hold this way, suppose one of you come here and hold your hand. If I apply a force here, from this member, force is transferred to that member, finally will reach you. See, so here load is transferred from ... you have to write. No space here. From one part to other part. You can tell that way. Or you imagine these two are two separate parts or two separate members or anything. You write whatever you want. Load is transferred from one part to other part in compound. But composite, see, this way. You hold together, now apply the force, see, this way. Now if you apply the force is taken by both of them. See, just to understand, suppose this force is 10 kilonewton. Just simple. Then this also will be 10 kilonewton. You can make a note here. Force, axial force on steel is 10 kilonewton. Same will be transferred to copper unless there is a junction force is there. But simple case I told. So from here 10 will go there. Here not that way. If you apply a load of 10 kilonewton here, say axial compression, then load is not transferred, load is shared. So load shared means maybe, see, this force and this force will be different. See, just to understand, imagine 6 kilonewton, imagine 4 kilonewton. So here, apply 10, if there is no other force in between, force from steel of 10 will be transferred to copper, same 10. See, simple language, force is transferred. Here, see, force is shared. It is not transferred. You can make out here. If you hold together this way, when you apply a force, a part of the force will come to upper one, another part will go to lower one, so that 6 plus 4 equal to 10. So make a note. First principle, transferred here, load is shared by dash 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 means both the parts or both the materials, whatever you can tell. Or important is here load transfer, there load sharing. Point number 1. Point number 2. You take a cross section here. See, take a cross section here. Take a cross section here. Anywhere from here to here. Take any cross section. You can see only one material. See here. If I take cross section right here, anywhere in the steel, you take cross section, section 1, you can see, you should write it, only steel. Whereas you take cross section here, anywhere here, in copper, you can see only copper. Or when you take a cross section anywhere you want, for that cross section, there will be only one material. But remember, here see, when you take cross section 1 or 2, wherever you take cross section, it will have, need not be 2, it can be more than 2. There will be multiple materials. Then you can write, consider simple steel and copper. Any section on left side, only steel. Any section on right side, only copper. Here, any section on left side or right side or wherever you take, you can see both steel and copper. Or, see now, when you take the cross section, in the cross section, wherever you take, you can see multiple material. That's why it is called member of composite section. Best example is RCC. Or one more thing I will tell you. Suppose bottom you take a RC column or a steel column. Above the steel column you put a timber column. Apply load. Force will come to timber column first. When you take a section there, only timber you can see. Then from the timber, load is transferred to steel column below. Take a section there, you can see only steel. That will become compound. Take the case of reinforced cement concrete column, RCC column. There you can see steel reinforcement. There, if you apply a load and take a cross section, load will be shared by steel and concrete. It is not transferred. See, first previous case I told, upper side timber column, load is transferred to lower side steel column. Here, when you apply the force, see cross section, when you take, you can see concrete and steel, it becomes what? Member of composite section. Load is what? Load is not transferred, load is shared there. That's all. Further not required. Right. Then, now lastly, one easy method. See, I told easy to remember. This is most easier. If, see, different parts are in series, it is compound. Somewhat crude, but easy to understand. Series, one after other one, that is compound. Whereas, if they are parallel, see here, if they are parallel, see, this is called series. This is called parallel. So, series is compound, parallel is composite. You make a note and correctly understand. Now, further, I will not explain when I do a problem which is compound, which is composite. Right now we are in the compound. I will complete compound now. When you go to composite, I will tell you at that time, be careful. Compound load was transferred, now load is shared. Then I will tell the principle. And for those who are in civil engineering, member of composite section is a very powerful one because it comes in RCC, even steel also it comes somewhere, and then in precious concrete, etc. So be careful, study thoroughly. Okay, now I'll give you, now that's all. I differentiated compound and composite. So therefore in examination, what really is compound, if they tell composite, or what actually is a composite technically, if they call compound, let them call. When you solve, you identify what is that member as per my instruction here, or what I told, then solve accordingly. And as I told earlier, you are not writing there, the given question is a compound, you don't write. Suppose a composite is there, they call it in the question paper compound. Okay, solve, but solve like the way I will tell you how to solve. Which one? Composite. If it is really composite, if they tell compound, okay, let them call. Okay, now, just one more thing. Now consider, see, now consider compound members. Actually, compound is not a pure technical term. People are using it, okay, composite is perfect. Compound member. Okay, now, I will tell you how to apply. See, first of all, I told delta equal to PL by AE. Along with that one, U equal to P square L by 2AE. I told you little earlier, are applicable only if P, A and E are all constants for length considered equal to L. Length considered equal to L. Then I told earlier, see, even if any one of above 3, you should not ask me if 2 above 3, that is P, A or E are not R, because anyone is not constant, then what? Above expressions, I am telling second time this one, above expressions cannot be applied for entire length, entire given length, remember, entire given length. Now I will go for more clarification. See, right here, more clarification. First I will take simple one. See, imagine a member here, one more member here. See, side by side. Some force here, say 20 kilonewton. I will apply a force of, see now, I will call A, B, C. Some length I require. I will take this is 400 millimeter, just to understand. This is 300 millimeter. Total length is 700 millimeter. Okay, now see correctly. I will call this as part 1. I will call this as part 2. Okay, part 1, part 2. Now, if this is 20 kilonewton for equilibrium, this should be 20 kilonewton. Unless there is any force in between. Yes, imagine, see, suppose this is also 20 kilonewton and right there, if this area equal to this area, cross-sectional area, and if they are both are of same material, then you are wasting your time by considering 400, 300 separately. Directly you can take length of 700, axial force of 20, then area is area, E, whatever is the E, use delta equal to PL by A. That is earlier. See, suppose earlier, if they give a question this way question given, will anybody break into parts? Some will be laughing. Break into parts. Why should you break into parts? Break into parts is when it is unavoidable. No. So therefore right here, if this is 20 and 20, I tell example 1. Example 1. 20 and 20 and both are same cross section, same material, then 1 and 2 will not come. This 400, 300 cancel. Remove this line. Then you take a single member of length equal to 700 millimeter subjected to axial force of 20 kilonewton and solve the question. Okay, clear. Right. Now you write this one. Suppose this you write as an introduction. In between there is a force of, say, this way of somewhere here 8 kilonewton. Now for equilibrium, this is not 20. See here, right side 20, left side 8. So 20 of 20, 8 balanced. Now this will become only 12 kilonewton. This I will explain little later. For that master question I wrote earlier, I rubbed it. I will write once again. It will see when the in-between forces are there, how to find axial force for any part, crystal clear, I will explain to you. Don't worry. So typing, believe me. See, now, see here, what happens? Want red color? Same thing. See, now, right. Suppose I take a section here and section 1-1. I take a section here, say 2-2. 1-1-2-2. Now, if I take section 1-1, if I look this side, axial force is 20 kilonewton. Even there also 20 only. See, 12 plus 8 together, 20 compression. But if I take a section 2-2 here, for this side, axial force is 12 kilonewton. This side also same. See, 20 this way, 8 this way. This you don't have to bother now. I am going to explain in detail in the question now. Coming up, master question. Therefore, write here. Here you should write here for 1 and 2 parts. Axial force P is not constant. How much not required? How much you study after next question when you start the problems. Not constant. Okay. Now, area is same. Material can be same. Imagine both are same material. For example, imagine steel. This is also steel. And also imagine both are same material. Even then, unfortunately, A and E are same. P is not constant. Therefore, this will not a simple member, this will become compound member. Or you write the formula delta equal to PL by AE cannot be applied for L equal to 700 millimeter. For 700 mm you can't apply. See, suppose you apply, what P will write? Different P's are there. But then doubt comes. But what to do? What to do? Nothing to worry. Principle I am going to give, or I will tell now. You can write if you want. I am not writing. What to do? Little later. I will write in the board procedure. But you write. Consider AB of length 400 and consider BC of length 300. Separately consider. Then for each of them P is constant. For AB P equal 20 kN, for BC P equal 12 kN. Separately consider. Then finally algebraically add the deformations. Okay, that's all. Time being not required. What to do? You tell it later. Why? We are starting compound now. This is example 1. So example 1, I made what? I made P variable. Okay, now I will go to example 2. Simple case, make it. Example 2. See. I will take a member here for some length, then I will take another member here, some length. See. Again I will take, this is 400 millimeter, same length. This is not to scale, 300 millimeter. I will apply a force of 20 kilonewton here. Here also I will apply 20. No in between force. 20 kilonewton. Imagine this is steel. This also steel. Okay, now ABC. Length equal to how much? 700 millimeter. Now imagine this cross-sectional area is, for example, 800 mm square. Just write. This cross-sectional area A equal to here 600 mm square. Just imagine, see, you can make out little higher cross-section, lesser cross-section. Now, write a note. For both of them, P is, see, our P, A and E. Then comes L. For both of them, P is constant. How much? 20 kilonewton. And both are same material. E also constant. But unfortunately, the cross-sectional area for AB, that is part 1, and for BC, part 2 are different. For part 1, cap area equal to 800 mm square. For part 2, 600 mm square. Therefore, you cannot apply the formula. See, this A is problem. This A is problem now. Therefore, you cannot apply delta equal to PL by AE for length equal to, you should write. I am dictating. Last time I wrote, this time you write. You cannot apply the formula, standard formula, delta equal to PL by AE, considering length of 700, because for 700 length, in between, there is change of area. So what to do? What to do? I will tell you now. So this is a compound member because of virtue of area changes. Last time compound because of the P change. Now only A change. Now, what to do? Consider length of 400, put area 800. Consider length of 300, substitute area 600. That way solve. So you have to divide into parts. Write all these notes crystal clear. Make a note. Now, lastly, example 3. Example 3. To make it clear. Example 3. Suppose, imagine a member this way. Half of them is steel, not exactly half, other side is copper. Once again, same length, 400 millimeter. This is 300 millimeter. Okay. Apply a force of 20 kilonewton axial force here. 20. Compression tension hardly matters. Something I require. Okay. This is 1, this is 2. Right here. Now, whether you consider steel or copper, this side or that side, P is same. Once again write. See, we want P L by AE. Okay. P is same. And one more thing. Just imagine this area is, say, 700 mm square area. This cross-section area is also 700 mm square. Actually, it can be different later. That means both of them has same axial force P and also same area here. Now only one pending, material property E. Oh, this is steel, this is copper. For these two, the problem is material property E, Young's modulus. They are having different Young's modulus. So you cannot apply delta equal to PL by AE for entire length of 700 millimeter. What do you have to do? Consider 400 length, use property of steel. Consider 300 mm length, use property of copper. Therefore, the two member has to be separated, or this also is compound. I discussed about compound case coming when only one among P, A and E, when only one of them is giving trouble. Not one of them, two of them can give trouble. Some rare cases, all three of them give trouble means what? All three of them may vary. I told, even if any one is not constant, you can't apply. You should not ask me, sir, if two are not constant, three are not constant. I told you last class, that is a nonsense question. So, even if among the three, any one of them is not constant, then separation required, that it becomes compound member. But remember, all those parts should be one after the other, series. If it is this way, it is composite, I told earlier. Okay, now, this is fully clear now. Now first I will give you procedure for you for solving member of composite, compound member. Simple, I will give you simple procedure. One more thing, forgot. See, these examples, I changed only one of them. If you remember, one sketch I wrote earlier, I by chance removed it. Because I could not continue recording on that day. I had other classes. I wanted to maintain that one. Could not maintain. I will write once again question, no problem. You see that question. It is there in the beginning of the class. There. It is a master question because T is changing, A is changing, E is changing. It is and one more thing. How to find P also. Complications. Not complications. I will make it simple. It looks like complication till you understand. I told you, like driving a vehicle. You drive a vehicle in only ground, residential area. In traffic, you will have a problem. I will teach you how to drive in full traffic so that residential area or ground you can enjoy. This full I will remove now. Yes. I can go for procedure for member of compound member. See, you saw how I told. I was about to tell procedure for member of composite section. Why? Because structure engineering compound member usually will not come. Member of composite section is very important. That's why, see, naturally I was about to tell composite. Compound. See, I will give you brief procedure. Then you should expand the procedure. That one you should write yourself for your reference as I start solving more and more problems. What all extra point I tell, you should make a note and thoroughly solve. See, I write procedure in red color. Procedure, brief procedure, sufficient. Brief procedure for compound members. Compound members. Remember, I am telling brief procedure. Okay, step number 1 if you want. Step number 1. As I told earlier, if I will ask the question in the class, what is step number 1? They will tell, sir, decide compound or composite. No. Step number 1. First, this I have. Spelling problem. Okay. Step number 1. First, ensure equilibrium. I told 1,000 times earlier for entire member. Here, consider action and reaction. This also I told earlier. And one more thing, I will not repeat every class now. When you consider equilibrium, it is always direction based. If you still don't write correctly and understand, your problem. What I can tell, it is direction based. Over. How we will see there. Or one more thing you can write here, action and reaction. Reaction you know from the support. Okay, leave it. First point. Second point. First I told, now. Second point, you should write, draw a neat sketch of the member with both action and reaction. Right here. Okay, you write, draw a neat sketch showing both what? Showing both action and reaction. Or you draw a neat sketch of the entire member which is in equilibrium. And then next step, and 3. consider or not consider, divide the member, divide the given entire member into different parts. Remember, minimum number of parts. I will tell you one more thing. Somebody will be laughing. If they give like this, see for example, this way, divide two parts. Don't divide 1, 2, 3, 4, 5, 6, 7. That becomes nonsense. Minimum number of parts, so that you should not unnecessarily divide. See, suppose you want area of a rectangle. This is 60. This is 40. Have you seen anyone dividing into two parts, then telling area 30 into 40, again 30 into 40? Someone will tell where you came from. Not that way. But suppose you want area for this one, then you are divide like this. Okay, now different parts. So that for each and every part, that is divided part, for each and every what? Divided part. What is the condition? Axial force P, cross section area A, and material E, property E are all constant. Okay. Then 3, 4. Now analyze each part separately. Now you can apply. Now we can apply delta equal to PL by AE, or U equal to P square L by 2AE, or original formula U equal to half P delta. I will tell one more thing. This I will tell you in the class later. But remember, here L stands for what? Not entire length. L stands for length of each part. Length of part considered. Now, lastly, 5. Finally, get required result. Required answer. Okay. This I will explain in the problem. I will tell you at that time. Go back to procedure and what all I am telling now, right there. Why? Some important concepts are there. So I will tell you. See, 5 I told, finally get required answer. How means, when I go to the first question, I will explain there, then I will tell you. Even if I don't tell you, you should remember. I may not tell you. Then you make a note. The moment I finish the first question, when each and every parts are separately analyzed, then how to get the final result, what all I tell there, you come back here and write. So leave sufficient space here. If requirement is there, leave 1 page gap only, 1 full page gap, so that some important principles I am going to tell there, you can enter here. Okay, now we are ready for analysis of compound members. I will start with the same question which I wrote earlier. I have taken a photo of that one. I should see the photo, and I am not told at that time what is required. I will first write the question here with all what is required and systematically solve, so that in the exam, if they give compound member, you can solve it. That much complication they will not give very easily. As soon as that master or critical question is over, I am solving simple exam type questions. Maybe some 5, 6 I will solve. But at that time, briefly I will solve. Because you should expand and make fair copy. You will be enjoying like anything. You will tell how easy. Yes, easy, correct. But solve. If you tell easy, okay, you should not tell I solved that critical question. This I am not studying. Very easy. When you think that way, then sometimes in exam, which you feel tough will not give trouble, which you completely ignored or underestimated, easy, that only will give trouble. So all the question I give there, I will dictate here, you make a fair copy and prepare solution. Answer I will give you. Okay, I will write and start. Okay. Now we will start the question 1. Remember, question 1 is note, master question or critical question for complete understanding of compound members. I will guarantee you, if this question is thoroughly studied, everything understood, then you can almost consider you have got perfection in compound members. For traditional questions, sometimes some conditional questions they ask, that I cannot tell right now because there is limitations here. I am covering the main course. Maybe I may solve one or two like that, but systematic solution for a compound member, any type, this much lengthy question exam they will not give. Then somebody will ask, sir, why such a tough question? I told earlier, I will teach you how to drive in full traffic. Later you will be asked to drive in a ground or area or roads where there is no traffic. Enjoy. So if you struggle once, it will give you good rewards later. Repeatedly I can't tell. That's how I always teach. Start. For the given question is, for the given member, see a big member is given, find 1. Stresses in different parts, extra. Compound member, stresses may not be asked, but they may ask you. Second one, change in length. They are not told change in length for which part. See, understood? If they give a question for the given member means complete member. They want what is the change in length for the entire member. Okay, lastly, strain energy stored. You should make a note. They are not told strain energy stored in which part. Understood? They want the answer for entire member. Okay, start. See, take E for steel, E for aluminium, E for copper, E for brass. Now, one chance of making mistake, what people do is, when they start solving here, they keep on taking E values in this order. Completely a mess. Why? Deliberately, see, in the order they told copper, aluminium, steel, brass. When they give E value, they gave in some other order. You can't question. They will tell, search. When you consider a member in any part here, see what is the material. Select the E value. They will tell, why should I give same order? Engineering students, why should I give same order? He will tell, deliberately I interchange. Sometimes it happens, they will give steel, copper, they will give copper, steel. In the E value, they will give steel, copper. People in a hurry, for first one, they will take the other first one here, gone. So be careful. Over. Now, solution. Note, I already told you, first ensure equilibrium. 1 minute. Observe. There is one support given. You should make a note. Whenever a support given, then equilibrium may not be maintained by the given force system. That is called action. Sometimes what happens is, in the question, they will set the question, maintaining equilibrium. Then, sir, thank you. Thank you. I will tell you, after I find reactions, I will explain that one. Make a note. But safer side or common sense. See here, 60, 70, 80, 30. I told 100 times, equilibrium is always direction based. So, right 60, right 80 is right 140. Left 70, left 30 is left 100. Oh, equilibrium is not there. So, you require a reaction to maintain equilibrium. So, therefore, right here, to get reaction at left hand support, say A. Do one thing. I will take the point as A. I will do one thing now. In exam, what you do is, this sketch is given in the question paper. When you copy the sketch for solution, you write A, say B, you write C, D, E. You write these things. Okay. Now, reaction at A. See, based on equilibrium, I will give you different options. What all you can do. See, option 1. What you can write? How option 1? find net force to right side, net force to left side, find the unbalanced force and balance it. If they give vertical member, net force upward, net force downward, find the unbalanced force and balance. See here. Net force on member is, see, I told you direction based. 60 right, 80 right is 140 right and 70 left, 30 left is 100 left. 140 right side, 100 left side. Somebody studying engineering, if he cannot decide what is the unbalanced force, quit the course. See, therefore, unbalanced force. See, 140 is acting like this, 100 is acting this way. So, unbalanced force is 140 minus 100 is 40 to right side. Not reaction. Sometimes students will, I will ask the students, tell the answer, unbalanced force. They will tell 40 kilonewton. Which side? Sir, right side. Why? For equilibrium. I will tell them, did I ask about equilibrium? No, sir. What I asked you? Unbalanced. Tell that one. What I ask, tell that much only. When I want equilibrium, I will tell you. So, unbalanced force is 40 to left side. Why? 42. Sorry. Print mistake. 40 to which side? 60 right and 80 right is 140 right. 70 and 30 is 100 left. Unbalanced is 40 kilonewton to right side. Correct. Therefore, actually nothing happened. I interchange by chance. I will correct it. So, how much? 40 kilonewton right side, or this complete force system will try to move the entire member by a force of 40 kilonewton right side. Therefore, for maintaining equilibrium, this support has to give it, for equilibrium, reaction at support A, say RA, should be 40 kilonewton to left side. Very, very important. This is one of the options by finding the unbalanced force and then balancing it for equilibrium. Okay, one option. Leave it now. Now, correctly make a note. I will go to other option now. See. Or I will go to option 2. I write here. Or option 2. I use black color only. Option 2. Second option. No, don't worry about right to left, left, right. Simply assume the direction of reaction at support. See, let us assume reaction, say at A, say RA to right side. You can assume either right side or left side, your choice. So, in that sketch, what you do? You consider a reaction to right side of RA. See, this way. RA. Your choice. You can take either, actually you know, sometimes students will tell, sir, RA is coming left side, sir. How you know it? Option 1. If you are doing option 2, option 1 is not there. Actually, I know reaction is coming left side, but still, take right, no problem. I will tell you, if you take left also, what happens? One by one, wait, start. Right side. Then, you assume reaction to right side. Then consider, apply equilibrium condition sigma h equal to 0. See, in strength of materials, I use sigma h and sigma v. In engineering mechanics, I use sigma fx and sigma fy, universally used. Sigma h means, you should write, if you want you can write, algebraic sum of the forces, algebraic sum of the component of the forces in horizontal direction for the entire force system equal to 0. These all you can see in my SFDBMD course in the introduction part, not introduction part, pre-requirement classes, so many classes are there, go through it. Or you are supposed to know these things. Start. Then sign convention required. You can take whatever you want. I will take right side positive. Okay. Then we get what? See here. Plus RA plus 60 minus 70, then plus 80 minus 30 equal to 0. Or now you will get RA plus 60 plus 80 is plus 140 minus 70 minus 100, or RA plus 40 equal to 0. Solve it. Your RA will come minus 40 kilonewton. RA will come minus 40 kilonewton. Now write a note. What is the meaning of the negative sign? I told it earlier in the beginning class. Equilibrium condition, sign conventional, I told you. Anyway, once again, right. When you consider reaction RA, we considered RA to right side. Negative sign indicates that the assumed or direction, considered direction for the unknown is wrong. Therefore, it is minus 40 came. Therefore, for any further calculation, you consider the reaction in a direction opposite to the assumed direction, but without sign. Therefore, you tell reaction at A equal to, see, we considered RA to right side, negative sign came, means it is not right side, it is left side. What is the answer? No sign now. Now no sign. 40 kilonewton to left side. No minus sign. Conclusion. Over. Now see the answer. That is same as what you got earlier. So when I go to next step, what I will do? At A, I will not write RA right side. I will write RA left side of 40 kilonewton. Should be clear. Okay. Now see what happens now. Suppose you consider RA to left side. Option 2. Note for option 2. Right here. Note for option 2 once again. Right here. Suppose reaction at A, say RA is considered to be left side. See, then see what happens. See, you take RA to left side, RA like this. Then see what happens. Tell the answer. Sigma H equal to 0. Minus RA, why? Right side positive. Minus RA plus etc. remains same. You get minus RA plus 40 0. So RA will come plus 40 kilonewton. Right? Positive sign indicates that assumed direction is correct. Therefore, further calculation RA is correct exactly in this direction only, 40 kN to left side. These are different options of finding reactions for axial forces. Correctly understand. Okay. Now what I will do is I will continue the question. But before continuing, make a note. I will not tell again and again. This all I will remove now. See, this I will remove. That sketch of, see, even this sketch also I am removing. See, removing. I am going to put a new sketch, but I am not removing. Why? You should put a new sketch now. For me, I can do whatever I want. See, now. This also I am removing. Remember. Okay, let it be there for some time. 1 minute now. Okay, start. Sometime in exam, what will happen is, they may not give support. But if they don't give support, then it is mandatory on their part to ensure equilibrium. Otherwise, question is nonsense. See, for example, sometimes they can give a compound member like this. Exam point of view, see. Something like this. Not too much more. Okay. Sufficient. This way they give. They will tell a force of 30 kN here. Maybe they will tell a force of 50 kN here. They will give a force of right side here of say some 15 kN here. Then here they should give 1 minute. And they give 5 kilonewton here. See. Now, support is not shown. So, no need of finding reaction. Then, do one thing. Now, it is their responsibility to maintain equilibrium. Let us check it. 30 right side, 15 right side, 5 right side. 30 plus 15 is 45 plus 5, 50 right side. Oh, 50 left side, correct. The given force system is in equilibrium. Thank you. Then directly go to next step with no reaction. See, with no reaction. If it is not maintaining equilibrium, then given question is wrong. If the equilibrium is not maintained by the given forces, then they have to show a support, so that at the support you find reaction and then maintain equilibrium. Hope this is clear. Okay, start. Now, I am going to write a neat sketch now. Very neat sketch. And one more thing. When I write a neat sketch later, I do not want any centimeter. So, in my next sketch, this I will remove. See what I am doing now. This is a new sketch now. You should not adjust here. See, I will remove this one. I may forget also. 1 nimisha. 25, 20, 22, 18. I am very good in forgetting. So, I will not write this way. I want a crystal clear sketch. What I will do? See, I will write this length. How much? 25 centimeter, or it is 250 millimeter. This I will write here, that is 200 millimeter as per given question. This length I will write as per question 220 millimeter. This I will write 180 millimeter, so that I will maintain millimeter. Centimeter I will not write. And then they told, see, this cross section is 2.5 centimeter by 1.5 centimeter. Remember. But when I solve the question later, I won't write centimeter. I will write 25 millimeter by 15 millimeter. I am not writing here. Why? When I solve the question, I will write. Or you can write here. See, you can write once again 2.5 centimeter per centimeter, 25 by 15. You can write here what? This is 25 mm by 15 mm. You can write if you want. Here you write 20 by 20. Why? Centimeter given. 20 mm by 20 mm. Here I write 1.6 centimeter. 5 means what? 16 mm 5. 5 means diameter. Means cross section is circular. Here I write 21 16. 21 by 16. 21 millimeter by 16 millimeter. So that I don't have to refer every time. Okay. Then these forces I will maintain same force. See, the contact point is very, very important. I will tell you why. Now, here I will write, see, we already know reaction at A is 40 kN on left side. So, here I will write, not red color, no, in the black color only, see, RA equal to A, go that side, A go that side. RA equal to, how much I got? 40. 40 kilonewton. I will enter here. RA equal to 40 kilonewton. I will enter here. Check the camera. Sometime what happens is goes out of camera. Okay. No problem. Space is there. 40 kilonewton. I will enter. Now, their copper aluminium, I will not write there because it will disturb me. So, see, I will write if you want in the bracket. This is copper. This is aluminium short form. This is steel and this is brass. And then I will do one thing. I will tell now only. They are given E Young's modulus in GPa. We want MPa. So I already told you how to convert GPa to MPa. For first member, that is which one? Copper. I will write 105 GPa. There I will write immediately equal to 105 10 to the power 3 MPa, that is Newton per mm square. Other three I will not show the calculation. For other three I will write 10 to the power 3, I will apply and write it. Now next time when I solve this I will remove. Why? One stored is sufficient. For someone who is serious, I don't have to tell critical question every time. Okay, now the question entry is over. Question is ready for solving. Now, see, I should remember this one. 270, 190. Okay. I'll make a small note here. I may not forget. 270, 105, 90. I will know. Somebody will tell, sir, note the material. That much idea I got. Which is which material, I know. Okay, now, what you do is, now you are solving, I will do systematically. This question you may tell very lengthy. No, it is not lengthy. It is becoming lengthy because of my marathon exploration. So that everything is convincing for you. Okay, now, start. First step. They want stress in the different parts. That is sigma. They want change in length. They also want strain energy stored. So, instead of wasting time part by part writing statement all, in the beginning only you write basic statement. See, we have, I will use red color. We have in general, stress sigma equal to P by A. Then I will put change in length because some members will be in compression, some will be in tension. Sometime in exam they will ask you elongation. Then they will see that everything may be in tension. Then you can use elongation. But here, change in length, delta equal to PL by AE, and also strain energy stored in general, U equal to, we will use P square L by 2AE, or remember the basic formula is, see, or remember U basic formula is half into P into delta. This I will explain in the class how to apply for this question. Whether to apply this one or this one, I will tell in the class. Okay, now, if you put this much, they will be very happy. They will tell formula, so later you don't have to explain. Then further, it is better to briefly tell the meaning of each term so that your solution is perfect. See, where common statement, where P is axial force, I told repeatedly, no right side, no left side, either compression or tension, nature based. I will stop now. Then, don't tell L. A is cross-sectional area, E is modulus of elasticity of material. Now the most important is what? Length L, not full length. Or L, last important is L is length considered. This is the most important, length considered. This is the most critical one, length considered. Okay. Now I will tell, therefore you should make a note here. We cannot consider entire length single stretch. Why? Axial force, area E, everything is changing. See, different axial forces here, different cross-sectional areas, different materials. So what you have to do is, you have to go part by part. Now, when I write for this member, I have to use AB, this is BC. Or to save the time, I can do one thing. I will call this as my division part 1, this is division part 2, this is part 3, this is part 4. If I divide this way, now if I put suffix 1 means understood AB, suffix 2 means BC, easy to understand. Okay. Now we are ready. Remember, all basic terms are defined here. Now we will go for systematic solution. Okay. I will rub all this one now, make a note and start. One member I will systematically explain for you. See. One member. Start. First, consider 1. 1 means that is AB. Remember, material is copper. Over. Now, you write a sketch here. This way, remember, One member I am thoroughly explaining for you. Remaining 3, I will start and briefly solve, but I will explain the important one. See, this point is A, this point is B, this is your member number 1. The length considered here is 250 millimeter. And if I take cross section of member, it is 25 by 15 means a rectangular section of width 25 millimeter, thickness or depth 15 millimeter. So it will be a rectangular section this way of width 25 millimeter and thickness how much? 15 millimeter. Actually, plate scale, this is equal to this one only, out of scale. Nobody will bother different scale. Someone will tell, sir, 15 here bigger. Keep quiet, not to scale. Okay, now, one by one I want. First I want, important is axial force for member. See, first I want axial force, or some problem is there. I will put cross section this side. Cross section is okay, I will put same way. This is a cross section. Happy now? Okay. Cross section. Width is, you cannot see width here. Remember, you are seeing member like this. Length and depth you can see. Width you cannot see. Okay, width is, how much I told? I did, not how much I told, given. 25 millimeter by 15 millimeter. See, now, very important is first how to find axial force. See, now for that one, so I will write the length of member somewhere here. Okay, no problem. I can write here only. No problem. That I will show there. 250 correct? Yes. 250 millimeter. Okay. Now, I want first, most important is axial force. Suppose they give some force here, some reaction here, that's all. Everywhere same. Now, first, to get axial force P. Axial force P for member number 1. In today's class, this is the most important. I will explain. See, what to do. Take a cross section here. One cross section here. Take a section here also. Light line. Call the section 1-1. This is section 1-1. Show both the places. Once you get practice, this is not required. And remember, our question is a master question. So, axial force P. See now, if I take section 1-1 here, I write here now. See correctly how is axial force 1-1. See, you should see section in between. Do not take when later, don't take here. You take section later, see where space is there. Do not cut forces. See now. If I cut here, I told you, you have to look only one side and no direction, nature. If I look this side, axial force is 40 kilonewton. See, there is a force of 40 kilonewton this side. See, this way, 40 kilonewton. You can imagine now. See, just make a note here. Make a note here. For section 1-1, if I look this side, 40 kilonewton will produce tension. Make a note. It will produce tension. That's all over. Now, right side, you need not bother. So, directly write axial force P equal to, most important, right? 40 kilonewton in the 40 kilonewton. But remember now, when you solve, we are solving in Newton's and millimeter. Therefore, equal to 40 10 to the power 3 Newton in the bracket tensile. Make a note. Over. P closed. Now, those who are interested, see, make a note here. Just make a note. We got the answer. Don't tell anybody. We looked left side. We looked left side. Exam, don't write such things. They will get angry with you. You look left side. Now, or those who are curious, do one thing. Look right side. See, suppose you look right side. See what happened. Your section 1-1 is here. See, this one. See, full, we have to look only one side. But one side completely you have to see. Therefore, see, 60 kilonewton goes this way. Then 70 is coming this way. For this section, 70 comes this way and 80 is going that side and 30 is coming this side. Actually unwanted. You do one thing. You look left side and get the answer. So you enter here. Width. You write here answer how much? 40 kilonewton. See, I will put right mark. Right mark means easily obtained. Other side you don't bother. If it is 40, it should be 40 here, tension only, 40 kilonewton. I will round off. Round off means not calculated. Once you get from one side, directly written without bothering. This is unwanted. In exam, what you do? You consider here, look this side, 40 tension, write 40 tension. Someone will ask you, sir, there so many things are there, that so many things will finally become 40 only. Okay, now see, curiosity. Now see here, you make a note here. Those who are serious, this critical question, I am explaining everything so that no confusion. See here. If I hold here, see, 60 produces tension, right here. Exam not required. 70 produces compression. 80 produces tension. 30 produces compression. Or 60 tension and 80 tension means 140 tension, 70 compression, 30 compression means 100 compression. See, my hand is still paining because that compression I hit hardly. It still, suddenly I thought, why it is paining? That force. Now see, 140 tension, 100 compression, the net will be, that is what? 40 tension. Directly you got. Once you get 40 this side, without seeing, write 40 that side. Next three members, I will not explain this much. But I will not write in the board, but I will explain in the class. That you make a note if you are serious. Otherwise, see, this member look this side. This member also look this side. Two forces are there. This member and this member look that side. So you consider which side is easy for you. Because irrespective of whichever side you consider, for a member, axial force remains constant if there is no forces acting in between the ends. Okay, now axial force clear. Now remaining portion, this is all unwanted actually, directly write. Okay, P over. Okay, P over, I write here now. See, axial force P equal to 40 kilonewton or equal to 40 10 to the power 3 Newton in the bracket tensile. Then write area equal to, see here, rectangular section 25 by 15. Not clear means better stop the course. 375 mm square. I told everything in Newton per mm square. PL by PL. Area equal, E equal to, remember the material is copper. Copper. In the question I told, for copper it is 105 GPa. I will write this time equal to 105 10 to the power 3 MPa. That is Newton per mm square. Next time not writing. And lastly, L considered. See, L means length considered. Very important. Length considered, L equal to 250 millimeter. 250 millimeter. Okay. Now calculate what all they want. What all they want you calculate. Start one by one. First, stress sigma. I use blue color. I thought blue color. Okay, leave it now. Stress. See, I will show the calculation here. Sigma. That is, say sigma 1, because our member number 1 is P by A. Once again writing is not required, but still I am writing P by A for member number 1 equal to P is 40 10 to the power 3 divided by area is 375 equal to, calculate stress, 40 10 to the power 3 divided by 375 is 106.667 Newton per mm square. Very important, tensile. Sorry, 1 minute. Check the camera. Should not go out of the camera. After putting so much effort, later if I come to know that it is out of the camera, means how bad it will feel. Okay, now sigma over. Then they want delta. Say you call that as delta 1 equal to PL by AE for member number 1 equal to P 40 10 to the power 3 into length is length 250. That is the Kannada language. Those who are outside. Area is 375. E is 105 10 to the power 3. You get delta 40 10 to the power 3 into 250 divided by 375 divided by 105 10 to the power 3 will come 0.253968 etc. Third or fourth decimal sufficient. Since small number, I will use 4 decimal. 0.25396 is 2540 because 0.25396 came, means 40 millimeter. But very important, member in tension, therefore it is increase. It is increase. Now, also energy stored U equal to what? Say U1 equal to P square L by 2AE for member number 1. Okay, some space problem is there. I will come this side now. This I can remove, leave it now. I remove this one because why? I am writing once again later. Okay, start. Here. Continue. Here only continue. Or I will do one thing here. Okay. And U equal to say U1 equal to P square L by 2AE for member number 1 equal to 40 10 to the power 3 square into length 250 divided by area divided by 2. Should not forget 2 divided by 375 divided by 105 10 to the power 3. Find strain energy stored. 40 10 to the power 3 equal to square into 250 divided by 2 divided by 375 divided by 105 10 to the power 3 is 5079.37 Newton millimeter. Now note, or your U1 can also be equal to half P delta for member number 1 equal to half into P is 40 10 to the power 3 into L is delta equal to 0.2540. See the answer. Half into 40 10 to the power 3 into 0.2540. It comes to 5080. Okay. 5079.37 came because I took 0.2540. Actually, it is not 0.2540. It is 0.2539 etc. This 5080. Both are same. See, 63 paisa difference in 6,000 rupees. Forget it. 5080 Newton millimeter. Now, one important note I will tell. You should write. Sometime in examination, they may not ask delta. It is possible. Just for testing you, they will ask you a compound member given, find strain energy stored. So many people get confused. See, no delta, so what? If they ask only strain energy stored, then also all this P, A, P, L, A, E, all are required same way. Directly write U equal to P square L by 2A. Over. Instead of delta equal to PL by AE, you write P square L by 2A. And remember, suppose in the examination they ask you delta and strain energy, then you need not go for P square L by 2AE. Since you got the value of delta, you can easily get half P delta. Your choice. So in this question, I will do one thing. While finding u, I will imagine that delta is not asked. Therefore, I will use for delta PL by AE, strain energy P square L by 2AE. Suppose in exam, delta is asked, you can use the delta and get u. Suppose delta is not asked, then better use P square L by 2AE. Make a note. So, this is completely over. Now, later important is summary. So, summary, I want the answer. I am very good in forgetting. So, I will make a note. This is not for you. My reference, somewhere in the corner, I will write. Where there is, okay, right here. You don't bother no. Here, you should not see this one no. Stress game 106.667. Tension compression, no problem for me. Delta came 0.2540 millimeter increase. Strain energy came. I will take the first value only. Which one? 5079.37. I will take the first value only. Okay. Don't see this one. This is because later, when all the four parts are over, I will go for summary. Usually live class means I will ask students, tell me how much. But now who I will ask? And I take a photo. Why? You do not see. This is my own reference. You time being correctly understand this much. Now what I will do is for 2, 3 and 4, I will save the time because everything explained. I will get the value of P. I will get the value of A and E. Then I will put direct answer. You systematically solve later. The way I solved this one, same way you have solved because you are writing examination. I am teaching. So once I thoroughly explain one, similarly I will tell you here. I will reduce the amount of work for me for writing, reduce the class timing, but you should take seriously and write. No, I am going to write systematically how he solved for 1. I am going to solve same way for 2, 3 and 4. Okay. Full board, I will prepare the remaining or I will first what I will do, I will explain you how to get P here, how to get P here, how to get P here. Once P is over, some will tell, sir, once you get P, sir, now you can do ourselves only. Yes, do it. Okay. I will write everything and start once again. We completed number 1. Now, 2, 3 and 4. I will briefly explain. You should make all the required notes. 1 minute. Later, don't worry now. Start. One small point. In the beginning, first sketch, I wrote here 1.2 centimeter diameter. See, starting of the class, I have given a sketch. I wrote 1.2 centimeter diameter. Because see, this is 15, this is 20, this is 16, this is lesser. That's why to scale, see 15, I reduced it. So this is depth is 15, this is 12 mm, 1.2 centimeter. But due to oversight, what happened is, when I put the sketch later, after explaining some theory, see I wrote the question first, then telling you principles. When I entered the sketch second time, I entered 16 mm diameter. No, it is not 16. It is 12 originally. Actually, I can change it to 16. No, I already got the answers for 12 mm. I calculated. Now I can't change. So do one thing. See, note in the class I am telling, in the beginning, starting of the class, I have given 1.2 centimeter. Later, I wrote it as 16 millimeter, once or twice. In the previous sketch, you correct it and cut it and write 12 mm diameter. Your responsibility. Tomorrow, no one should ask how 12 became 16, again become 12. I will tell nonsense. Don't ask such questions. See, my wish, I can change. How does it matter? Oversight, I wrote 16. Now make it 12. So remember now, this is 12 mm diameter. Okay, that's all. Start. Figure number 2. Section 2 to cut here. See, don't cut here. If you cut here, See, some will think this force is right side. No, that force is acting here. You may write whatever length. So better cut in between without disturbing the forces. You make a note. Okay, start. First, see, that 2, 2 is here. 2, 2. One already over. See, look this side. If I look this side, see the forces. 40 is producing tension, and for this section, 60 is producing compression. See, same 60 for this member is producing tension, but for this member, see, for this member, this 60, if you look right side, is producing tension. Same 60 for this member is producing compression. That's why you should not consider left side force, right side force. I told you earlier, tension, compression. You consider the section. When you consider section, for that cross section, how is the effect of the force? See, now if I consider here, this 70 will give compression, see, from this side. Same 70 for this member, see, it will give tension. So that's why you should not tell last that 70 is acting left side. Last time that force you wrote compression, now how you wrote tension, because from where we are viewing, see, if I see here, if a force is acting this way, for this member, it will give tension. Same force for this member, see, it gives compression. Therefore, never consider left side, right side. You consider whether the effect of the force for that cross section is tension, compression. So here, if I consider here, look left side, 40 gives tension, 60 gives compression. So net answer is 20 compression. See, this is calculate answer. This is directly enter without looking that side. Okay, you can make a small note if you want. See, at 2, 2, I will write somewhere where space. Okay, I will do one thing. Just to understand, you make a note if you want. See, somewhere here I write. For 2, 2, see, look this side. 40 and 60. See here, the 40 is producing tension. 60 is producing compression. So net is 20 compression. That side, without calculating, I told you 20 compression. Once if you get compression on this side, same thing should be from that side. Whether you look left side or right side, force should be same. Or check the answer. See now, make a note if you want. See. 70 creates compression. 80 creates tension. 30 creates compression. So 70 and 30, both of them will give compression. That is 100 compression. 80 gives you tension. So net will be once again 20 compression. If you follow everything I tell in my class, I am telling in my class from beginning, this will be no problem. Over. So P over A is square section 20 by 20, enter the answer. E, it is aluminium. See, aluminium. Whatever E value, I told 70 GPa given, enter. Length considered, see I am telling for this segment, length considered is 200 mm. Okay, I am substituting here. Sigma, say sigma 2. P by A for 2, substitute. 50 Newton per mm square compression. Delta, say delta 3. PL by AE for 3, substitute. 0.1429 mm decrease in length. Energy stored, U3, strain energy. P square L by 2AE for this number, substitute, you get the answer. 1428.57. Correct. Now, or you can do one thing, you can also find this U by half P delta. I already told you, no point in wasting time. Okay, start. Next, consider member 3. See, this is 3. See, that is your CD. C to D. See, length 220 millimeter. Material is steel. No, I already done there, somewhere there. I wrote it here. Where I wrote? I not written. I written here. See, steel. Okay, take one cross section, circular section of diameter 12 mm. So I written circle of diameter 12 mm. Somewhere there. So the cross section should come this side, not there. 1 minute now. See, when you write data, that is separate calculation. Now okay. Side by side cross section 12 mm diameter. Start. Axial force P. See, axial force P For this one, you look right side. Why? You are nearing here. See now, if you look right side, 80 tension, 30 compression. 80 tension, right here if you want. See, look this side. See, 80 is producing tension, 30 is producing compression. So net answer is 50 what? Tension. See that? 50 K in tension. So this is, by look right side, this is calculated value. I will put right mark here. This is directly written without calculating. Or check this side. 70 gives tension. 40 also gives tension. So 70 plus 40 is 110 is tension. 60 compression. 110 60 difference is 50 tension. Okay, over. Axial force P is 50 kilonewton tension, convert to Newton. Area pi by 4 of diameter square. E for steel you write. Length consider 220. Now you substitute. That's the limit for me to explain. Then sigma 3 P by A substitute. Tension delta 3 PL by A substitute. Do the work. Put some effort there. And U3 P square L by 2A, get the answer. Okay, now last part I will write here. I will rub and write here. You should not do that way. See, I am changing now. Consider 4 to save the time. That is, you write once again DE. It is brass. Now see, force I put later. Okay. Cross section is how much? 21 by 16. Okay, right here. See there, cross section 21 mm by 16 mm. Okay, cross section. So axial force correctly come here. Section 4 is here. See, section 4. Okay, some will comment, sir, this 4. Okay, 4. Look that side. See which side is easier. Look that side. That side. Anybody going on the road will tell it is 30 compression. Therefore, this side, this is calculated value. Directly write 30 kN without calculating. Still for your information. See, if you want to understand. 80 creates compression. 60 also creates compression. Total 140 compression. 70 tension, 40 tension, 110 tension, 140 compression, 110 tension means net is 30 compression. Over. So axial force is how much? 30 kilonewton compression. Area 20 by, not 20 by 20, it is how much? Area is 21, here only section is there. 21 by 16. Who knows the answer? 21 by 16 is 336 mm square. E, this is, material is what? Brass. So E for brass is given 90 10 to the power 3. Length considered is 180 millimeter. Over. Now start. Sigma equal to sigma 4 equal to PL by E for 4. You calculate. I will not waste time. Substitute, get the answer. I got the answer there. I noted down 89.286 Newton per mm square. Compression. Then delta equal to delta 4. PL by AE for 4. Substitute. P is here, L is here, A is here, E is here. Calculator is there with you. Substitute 0.1786 millimeter. Sometime I talk that way only. Millimeter. And remember, it is compression, therefore decrease. Decrease. This is not there. Don't see this one. This is all gone now. I will do one thing. To avoid confusion, I will remove all this one. So why? Unnecessary waste. Okay. Then U equal to, say, U4 equal to P square L by 2AE for 4. You substitute. Substitute, answer will come 2678.57 Newton millimeter. Over. Everything is over. Now, one important. By chance, if anywhere calculation mistake is there, correct it. Don't make an issue. I will not entertain such things. In the classroom also, if someone tells, sir, that is wrong. What is wrong? Principle? No, sir, calculation. Correct it then. Tell me if principle is wrong. Start. Now, everything over. See, I noted down the upper side answer. That is for my personal reference. Because otherwise, I had to go to camera, see the recording and check or write somewhere. So now, everything is over. I will close now the question. Full I will remove. Okay. Full I am removing now. Nothing will be there now. I will just do one thing to understand correctly how to conclude. See, it's very important. Everything is over. Actually, this much difficulty is not there. I am going for more and more explanation. See, actually, remember, you write here. What he is writing here, we need not write. It is for understanding because it is already there in the calculation. Don't write. See, stress, delta and U. First one, don't write. It is all there in the sheet. Don't write anything. Because otherwise, how to show you? To show you the answer. Or millimeter only, it is tension increase. Unit I am not writing because it is my copy. Decrease when 57 U here. I need stress that much increase and last one. Actually, stress in one is 106.667 Newton per mm square. Nature is tensile. Remember, second part you got stress compressive, important compressive. Here we got stress tensile. Here you got stress compressive. That this is increase, decrease, increase. 0.1786 is decrease. Why decrease? Common sense. When tension is there, increase, compression means decrease. You need not write any of this one. Now see, write how to conclude. What they want in the question. They want stresses in different parts. Yes, we got it. Don't write answer. See, we got stress here. Sigma 1, sigma 2, sigma 3, sigma 4. We got. Now write one thing. We got it. The first requirement was stresses in different parts. We got it. But write a note. See, note. Suppose in question paper, question is question paper. They ask not stresses in different parts, some other way. What is the maximum compressive and tensile stress? Then suppose they want, right here, suppose they ask question paper maximum compressive and tensile stress. If they ask that way, then answer is, you have to write the answer. Therefore, you have to write what? Maximum compressive stress is, see, compression 150, other is 89. Answer is 89.286 Newton per mm square. Where here you write in DE, you can't write. In the question paper they are not given DE. In the question paper, they are not given 4. If you write okay, but better write in brass. Or see, they will be very, very happy. Yes, in brass. And maximum tensile stress. If they ask for entire member, undoubtedly this one, 442.098 Newton per mm square. It is in steel. Okay. Make a note. Suppose they ask least compression, answer 50. Least tension 106.667. And also write, suppose they ask instead of maximum tension, maximum compression, simply they ask maximum stress, that's all. They are not bothered tension compression. Then they are not bothered tension compression. If they ask maximum, answer 50. Oh, here 442.098 Newton per mm square in steel. Over. Write that way. Okay, this is over. Now come to next. They want, see, next conclusion. We got, see, different parts, we got the answer. Now we have to combine it now. No. Second part they want is what? Change in length. Change in length. See, when they ask you change in length, it is not part by part they are asking. They are asking change in length for, remember, entire member. Entire member they are asking change in length. How to calculate? Make a note. I am dictating something, make a note. Examination, such notes are not required. Understanding. Some members are in compression, some members are in tension. Where compression is there, length will decrease. Where everything I am telling, write it. Where tension is there, length will increase. So what you have to do is, you have to go to algebraic sum. You have to go to algebraic sum. Means you should tell the net answer and tell increase or decrease. Now, how to get it? One option. See, option 1. Option 1. See, net increase. Net increase equal to, see, one increase is here, one more increase is here. Add those two. 0.2540 plus 0.4863 equal to one of the option. 40 plus 0.4863. Suppose I make a mistake, means correct it. 0.7403. 0.7403 millimeter is the net increase. Calculate net decrease. See here, one decrease is here, 0.1429, one more decrease is there, plus 0.1786. 0.1786 is 0.3215 millimeter. Right. Therefore, change in length for entire member equal to, now high school level mathematics. This much increase, this much decrease, so it is 0.7403 minus 0.3215, because this is more, equal to 0.7403 minus 0.3215 is 0.4188 mm in the bracket, right? Increase. Why? Because increase is more, over. Now make a note. Suppose this is higher, then from this one subtract that one, then answer will be decrease. Suppose imagine net increase is 0.6, net decrease is 0.8, answer is 0.2 decrease, that way. And make one more note. Here mix up is there. Some of them are increasing, some of them are decreasing. So algebraic sum required. In case all are increasing, that is, if everywhere force is tension, it will come later. Or all are decreasing, that is when everywhere force is compression. Then do not do this way, simply add the 4. If all are in tension, write increase. If all are in compression, no minus sign, decrease. That's all. Now, I'll give you one more option for it. Option 2. Now, what's the answer? 0.4188, correct? Answer is 0.4188. Okay. One more option. See, this also is okay. Suppose sometime people will tell, no sir, I find difficulty. Okay, then what change in length required? Net. Or write here, you write increase in length. Or you can write here change in length for entire member in the bracket, write increase is positive. Here is your choice. You can take anything positive. Increase is positive. Then see, increase plus 0.2540. This is decrease minus 0.1429. This is increase plus 0.4863. This is decreasing minus 0.1786. Now you should write the answer with sign. Actually, I know the answer. Cross-checking it. 0.2540 minus 0.1429 plus 0.4863 minus 0.1786 is plus 0.4188 millimeter. Okay, see now, right? We took increase positive, positive came, therefore change in length for the entire member, you write for entire member equal to, no sign now, 0.4188 mm increase. Now, those who want to make one more note, I won't write. You can take decrease positive if you want. Then all the plus will become minus. All minus will become plus. Answer will become minus. Decrease positive, negative means once again increase. Common sense. No, do one of them sufficient. Over. Or when increase, decrease both are there, take increase positive. Best thing. Okay, over. Now, the last part of this question, of this mega question, is your thoroughly understanding problems question. To get strain energy store. See, lastly, total strain, that's the third part. Strain energy stored. Or you can write strain energy stored for entire member equal to C. First member answer is 5079.37. 5079.37. Second member is 1428.57. Oh, I should see here. See that I should see here, correct. Next member is I am showing finger there, here. Next one is 12157.71. Last one 2678.57. This is the 4 parts. Now very important, see correctly, this is in tension. If you remember, see, I told you this member in tension. So you take tension positive, this is plus. But in the offline class I will ask student, this member is not in tension, it is compression. Therefore, since you took tension positive, it is minus. This member is in tension, so plus. This member is in compression, minus. In the bracket write tensile positive. Okay, now calculate the answer and present the answer in Newton millimeter. I will calculate now. 5079.37 minus 1428.57 plus 1215.71, and lastly minus 2678.57. 21344.22 Newton millimeter. This is the total strain energy stored in the member. Now, if it is an offline class or a live class, I will ask the question, clear or not clear? Offline class, all will tell, sir, fully clear. As I told you in my class, nobody will ask doubt. If I take live class for you, will understand. Let me see who will ask doubt with me. For asking doubt, doubt should come. If it is a live class, I will ask you, clear or not clear? Usually I have seen, I have taken plenty of live classes, clear, yes, clear, clear. We will keep on start pouring in, one after other in the reply comment box. Series will come, clear, 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 yes, 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 like that. Then I will tell, see, you tell clear. Suppose I stop the class now, I will tell, class over now, we will continue next time. Okay, they will tell. Then I will tell them, if I do that way, people who are trying to find a mistake in my class, so many will be there, they are waiting. They want me to make a mistake. They will not able to get it. They will be so happy if that person knows the concept. He will be so happy, he will tell everybody, see, KSN wrote it. My name, KSN wrote it. Then suddenly some student will tell, sir, what? 21344, 21,000, sir, 5,000, 1,400, 12,000, 2,000. Sir, it is not coming 21,000, sir. It is coming less, sir. How much? I will tell what he will tell. Sir, it is coming sir, only 13129. Are you sure? They will tell, yes, sir, 13129. But you wrote 21344. Then somebody will tell, sir, there is a mistake from your side. They are telling me there is a mistake from your side, sir. You wrote clearly plus minus, but in the calculator you simply added, sir. You are not accounted for minus sign. You took all plus signs, sir. Okay, sir, no problem. We will correct it. I will tell them, don't correct it. That is wrong. This is nonsense. Taking tension positive, writing plus minus is utter nonsense. Do you think I can make that mistake? I will tell them, energy stored, there is no compression tension. And one more thing I will tell, see, P square is there. Sometimes people for axial force, tension they take positive, compression they take negative. But when you do P square, what happens? Negative square become positive. Some will tell, sir, half P delta. Okay, if you take half P delta, when tension is there, they will take P positive, delta positive. When compression is there, they will take P negative, delta negative. Oh, yes, sir. Therefore, be careful. In the live class means I would have trapped you. Offline class, such trappings is regular pattern. Why? Not for my enjoyment. If I make a mistake deliberately and correct it, it will remain there for a long, long time. Therefore, write no tension positive. Simply strain energy for entire member. You write here, be careful. Red color. Next time I will not tell red color. Be careful. Never and never use sign. Strain energy means there is no plus minus there. Therefore, do one thing. Simply add or write total U is without sign It's already plus. Some will tell student, sir, already plus. Keep quiet. This is not required. Now check the answer. Sir, now coming correct. Yes, because I was telling minus, plus, minus, plus, minus. You are not knowing when you are calculating. I am using plus only. See, I'll do once again now. 5079.37. I took plus only 1428.57 plus 12157.71 plus 2678.57. 21344.22. Usually what I will do if it is an offline class means when I write this one, I will ask a calculator. Give a calculator to me. The moment I ask a calculator for such simple thing, some will tell immediately. Some trapping is there. Why? Otherwise, sir will not ask for calculator. They will ask our answer. When he wants to calculate, which very easily high school student can calculate, that means some trapping is there. They will realize. So that's why sometimes I will write their answer and then I will tell them, don't do the mistake. So, last warning for finding change in length. Yes, correct. Some are increasing, some are decreasing. Use algebraic sum. Their increase decrease is considered. So, 10 increase, 8 decrease means 2 increase. But energy stored, 10 energy stored in compression, 8 energy stored in tension means total is 18, no plus minus. If you still make the mistake, you have to blame yourself only. Okay, I think mistake is, what mistake I made deliberately. I always tell in my class, if I make a mistake, it is deliberate. My students know it. It is deliberate. Why? What mistake you are making, I am making it. Then I will tell them, I am there to correct it. Okay, now corrected. So, if somebody left the class earlier thinking that, see, when I wrote minus minus here, suppose he saw the question, everything is over, they may think, now he may tell some story or he may tell something extra, not required, let me study, he will make the mistake. Penalty for him for not going through entire class. It's a penalty for him for not going to entire class. I told him, why you left earlier? I thought that the class is over. Is the class over? When the class over, I announce it. Okay. Those who are watching, be careful, make a commitment. Okay, now the critical or master question is completely over. I first thought, let me do 1 or 2 simple examination questions today to give you confidence. No, too much time already taken. So I will stop the class now. Next, class number 5, very, very important because I am doing all examination oriented questions. You see how fast it will be over. See, 2 minutes or sometimes what is this question? Where is this question? So they are all around. Maybe next class, class number 5, I will examination point of view, which question comes. Maybe some 5-6 questions I will solve here. If I get time, I will give some homework with answer. Okay. Now we will meet in class number 5. Something I told I will tell at the end of the class. I will not tell today because I have decided something. I won't diverge it now. There's something I decided. See, from the previous class to this class, I maintained a gap, deliberate gap. Earlier, I sacrificed my timing, other time, and provided for you. My SFDBMD class, I stopped there. My main purpose is, my main project is SFDBMD class. 100 classes are over. I put it sideways so that I thought, let me teach strength of materials for students to help examination. And in return, what I asked, you are not satisfied even 5% of my requirement. No, I saw class number 1, class number 2, class number 3, how many have gone through. Downloading and seeing means I won't be knowing. I told I am very strict in that matter. This is a service I am doing. You should think that way. It is not a commercial class. It is service oriented class. If people casually take it, you will be loser. I am not losing anything. You will regret later. Of course, there may be some students who are sincere. Very sorry for them. I can't help it. Therefore, I had decided something. I will announce in subsequent classes now. I will announce what is that one. This chapter I am completing. That is sufficient for me. I decided. That's all. This particular chapter, stresses and strains, I will fully complete. Because I never leave halfway in between. I don't have the habit. Other chapters, gone. You don't deserve, present generation people don't deserve this type of classes from me. They deserve that classes with just formula, substitute, do something without any basic concept, without any understanding. Comes in examinations, do it or go for supplementary. Okay, there people. So now I will close the class. Class number 5 will meet. Now I will start uploading little earlier possible so that this chapter full I am to cover now. I will cover as early as possible. Okay, thank you. See you in class number 5. I think 5 correct? Yes, correct. Sometimes confusion for class number, not subject confusion.